everyone. Good afternoon. Um, so in this session, we're going to talk about tools and libraries, and I'm basically giving like a quick overview. So I'm not going in depth into any tools. The idea is that I show you as many tools as possible, so that if you like them, you go to another session at JCON that covers the tool in depth, or you look it up on Google, YouTube, whatever. It's basically to inspire you for new tools that hopefully you didn't know yet. Myself, I'm a software architect. If you have any questions, feel free to approach me or ask the questions directly, or afterwards you can also contact me on Twitter or LinkedIn. All the examples are available in my GitHub repository. So if you go to github.com/my name, you can click on the Java Hidden Gems, and there are like 70 different tools and libraries, examples basically that you can try out. So I cannot cover all of them in these 45 minutes. I try to cover as many as possible, but if you're interested, you can have a look at these ones later. So basically, to get started, I've divided the different tools and libraries more or less in a few topics to structure them. So we cover a bit architecture, test, implementation, security, and builds. But let's simply go to an IDE and see some tools and libraries. So first one we're going to look at is ArcUnit. So if you have your tests somewhere, or then normally you test like functionality, but with JUnit and ArcUnit together, you can also test your architecture. So to simply look at some examples, I can specify a rule in Arc rule that says, okay, all the packages all the classes inside the controller packages which have the add-rest controller annotation should have a simple name, so the class name basically, which ends on controller. Of course, I mean, I have one class in that package which I named wrongly named, so it will give an error on this one. So it automatically verifies my architecture rules. If I would have named this one wrongly named controller, then of course it would be fine. So there are many different rules that we can define this way. So we can also define basically how your layers in your application look like. Before we had maybe the view, the service, and the database layer, and now you maybe have the onion layers and all kinds of stuff. You can basically check them. So here, for instance, I say, okay, any stuff that's inside the payment package can only depend on stuff that's inside the common package, in the Java package, or the Spring Framework package. It shouldn't depend on stuff in, for instance, the student package, because it shouldn't have any dependencies. And the same goes for common. So common shouldn't depend on payment, because then I might get circular references, which is basically horrible. So it should only depend on these packages. And you can even go one level further. You can define the layers. So I can say, for instance, okay, I have a controller layer in the package named controller, same for service. And then I can say, okay, the controller layer cannot be accessed by any layer, and the service layer can only be accessed by the controller layer. So this way you can define all kinds of rules, which are then basically checked at build time to see if your code still adheres to those rules. Because often what you see is that in the beginning, you come up with these rules, and then you start coding more and more, and after a while you find out that you have all kinds of weird dependencies on each other, and with this you can basically prevent it and make sure that you have a clean architecture. Then we go to some of the tools that help you with testing. First one we'll have a look at is Awaitility. So if we look at, for instance, the simple example as we did it maybe in the past, if we have some asynchronous operation, and in the past you might have done some thread.sleep in your test to wait until that asynchronous operation completed and then do your asserts, because otherwise the operation was still running somewhere in the background or would even be killed by your unit test framework. So here, for example, I basically do a thread.sleep in my unit test, which is a bit of ugly, because if you run the unit test on a quicker machine, maybe this can be like 1 second, or if it's on a slower machine, maybe it needs to be something else. So it's not really efficient, and it's a bit ugly, basically. So what we can do with Awaitility, so in this case, we basically add stuff to a list. So with Awaitility, we can say await at most 2 seconds until something changed in the list. In this case, I simply check if one element has been added, and then I do my asserts. So if I run this, you can see that, make it a bit bigger. So with sleep, it takes more than 2 seconds, of course, because I have the thread.sleep. And if I use our utility, it only takes a bit more than 1 second. So this is a really simple example. If your entire code base is filled with these thread.sleeps, you can win a lot more time. So this is a really easy thing to do. Yes, of course. So the question is this for unit tests only? I think you can use it for any test that you want. Yeah. It's simply a library that you use, and you can wait until that period is finished. So I would say you can also use it for integration testing. Yeah. Good one. Yeah. Next one we're going to is JCON. Who's familiar with JCON? A lot of people. Probably you know it from the coverage that you get in your unit tests. Who's aware of the JCON agent? Even a few hands. Nice. So the JCON agent is relatively unknown if you compare it to the normal JCON coverage. And with it, you can actually do some cool stuff. So what we will do is we start the Java application. Let's make sure we have this one. No, not that. That one. And then what we basically do is, I'll show it here. That's just as easy because it's already started. So we start the JCON agent, which is basically just a jar file that you can download. We say, okay, this is the target folder, and this is the classes that I want to check. And then I start my normal application. So basically I have my normal application running, and I have some agent attached to it. And then the application is really simple. It's just a REST application which has some endpoints. So if we go to the endpoint and we call it, we get some JSON data back, but that's not the important part. That's basically for the demo. So now I can stop my application, and really make sure you stop the application, because the result file is only written once you stop the application. It's not written continuously. First time I tried this, I tried it a lot of times and never got a file, and then I went for a coffee, and suddenly, because I stopped the application, the file was there. So don't make the same mistake. It costs you a lot of time. Now you basically get some binary report which is completely unreadable. So we run another command basically to make an HTML report out of this one. And that's now also done. So let's look at that one. Let's see. This one. So here we again have that coverage report, which you probably know from like unit tests or maybe integration tests. So let's look at this one. And here we see that, okay, my get endpoint was called, but my post endpoint and the exit endpoint weren't called. So basically now I have a coverage report of a running application where I simply clicked around. But you could do the same for like a performance test. Or what we did, we had a feature test written, I believe it was in Cucumber in a previous project, and it had really almost every feature was tested according to the specification. And what we then did, we ran all those tests with Cucumber while measuring the coverage, and we found out that actually quite some part of our application wasn't covered. And we were like, how is that possible if we cover almost every feature? And then we found out that it was actually dead code. So we could remove the dead code. It was no longer necessary. So there are various applications where this measuring is really handy for. So you can use it in any testing environment basically to measure the coverage of your application. Oh, sorry, wrong screen. Then we go to the next one, PyTest. Who's already using? Yeah, sorry. Yeah. I don't know. You would have to try. Yeah. So the question was, does it work on Android? I think, but I'm not sure. I never tried it. So next one is PyTest. Who's using mutation testing already? Few hands. So the rest probably can start using it tomorrow or on Monday. So maybe you are familiar. When you do unit testing, often you have these companies and managers that say, yeah, you need 80% coverage. Yeah, I mean, 80% coverage, okay, I cover the 80% easiest code and I'm done, right? Or I simply call the methods without doing any asserts and I have 80% coverage. Doesn't say anything, right? With PyTest, what we basically do is we test the quality of our unit tests. So how does it look like? We have a really simple example here, basically, with some if-else statements. Basically, depending on what values get in, some value is picked as the result. Don't bother too much about the details. And then I have one basic test, basically, which tests, okay, if I put in 2 and 5, I get 42 out. Of course, this is way too less testing for all the if-else branches that are there. So basically, you already know that, oh, not that one, that it's not enough. But let's see what happens now. So I can run this command or integrate it in your build environment, for example. And what now basically happens is so-called mutants are created. So this is my production code, and then PyTest will change that code in several ways. So for instance, instead of this bigger than sign, it will replace it by a smaller than sign. For the return statement, it will, for instance, return 0 instead of the actual number. And for each of those changes, called mutants, the test will be run again. And if the test succeeds, it basically means that your test isn't good enough, because production code changed without failing the test. So of course, this means for each test you get like 8 variants or something like that. So the test will take some time to run, so run it in like a nightly build or something like that. But then you get a nice result. So let's see where the result is. Can I look at this one? So here, for example, we see, okay, which parts are covered properly. So apparently here I somehow did something okay, but here I already missed some things. And it also says why. So for instance, on this line, so line 11 here, the get variable, it replaced it by simply returning 0, and then my test still passed. And so there are a couple of different changes that it made, and you can also specify which changes it is allowed to make, and based on that it will test if your code is actually written properly. So this really helps for if you, for instance, forget to do the proper asserts or things like that, this automatically notifies you of that. So it's really helpful while refactoring or writing more complicated code. Instead of trying to figure out all the branches yourself, if you have them covered, this will warn you automatically. Then we go to test containers. So maybe in the past when you did testing on, let's say, databases. Let's say you have a MySQL database. You want to do some kind of integration testing, and those integration tests, you want to run them on a developer machine, but maybe also in the build environment. Then you need to have some MySQL instance running on each of the laptops. You need to have it running in the build server, etc. It's inconvenient. You need to set it up. You need to maintain it, upgrade it to newer versions, etc. With test containers, basically those databases or other systems, you can also do it with messaging systems like Kafka or something like that. You can also run that in a container, and test containers automatically manages it for you. So for example, for a MySQL container, I can specify which version I want to use. So there are some basically default containers like MySQL, but you can basically put any container in here which you want to run automatically. And then basically from that container, I can retrieve all the credentials and the URL, etc. I can connect to that container and then do whatever stuff I want to do with the database. So this is really simple. I didn't want to put too much framework stuff in it. Simply put some stuff inside the database. So this way you basically create an abstraction layer for these kinds of tools. And it's now really widely used. For the next example, I'm actually going to combine a few tools together. So we're going to look at Gatling. Any of you here worked with the JMeter? Who liked working with JMeter? Okay, I think every hand is gone more or less. Yeah, I can fully agree with that. So JMeter is an okay tool for its purpose, but if you have used tools like Gatling, you quickly notice that they are a lot easier to use. So for example, this is a test file for Gatling. What I do here is I specify a simulation which basically loops 5 times, and it does a call to the /car endpoint, does a pause, it also checks the status, and then goes to the car part endpoint. So this is like a loop which is executed 5 times. Underneath it you can see that I do ramp users during 10 seconds. This basically means, okay, after 0 seconds I have 0 users, after about 5 seconds I have about 4 users, and after 10 seconds I have 8 users, and those 8 users all will execute this loop. So in total I have 40 iterations. And no, not that one. I first need to start my application. So if I start my application, it's again simply a JSON endpoint. It's there. Let's see. the command for it, maven getling test. And what we will do in the meantime is we will also look at mission control, so JDK mission control. Before it was part of the JDK, you could use it for free on any environment except production. Then you needed to pay Oracle a lot of money for it. And why? Because it's one of the best profiling tools out there. You can profile your application with only like a few percentage overhead, depending on how many checks you enable, of course, but it's really efficient for profiling and monitoring applications. It's no longer part of the JDK, but you can download it separately, and nowadays you can use it everywhere for free. So it's really nice to use this on your test environment or your production environment, wherever you want. So here I have my application running, and I can say, okay, start my flight recording. I can specify whatever I want to basically collect for data. I simply set some settings that I collect most of it, and then I can click finish, and now I quickly need to also start my performance test. So you can use them separately. You can either use getling, or you can use flight recorder, or you can combine it, whatever you want. I combined it because I don't have enough time to show everything basically, and this way I could show two things at the same time. So here we see 4 users are waiting, 4 users are active. We can see how many requests went okay, how many failed, blah blah blah, and now it's done. And then we can look at the target folder. Where's it? Getling. We can look at one of the files that's being created. And this, I think, is the biggest difference with JMeter. I mean, I worked with JMeter in the past, it's okay, but then management asks you, now provide me a nice overview and some graphs. And then you're playing with Excel for like 4 or 5 days to get all the crap in a nice view. And with Getling, this comes basically out of the box. You can even generate PDFs with it, but I mean, HTML is cool enough. So we can see that there were requests to the car endpoint, to the car part endpoint. We can see which ones went okay. We can see things like minimum response time, maximum response time, 99 percentile. I can see how many users were active at a certain point of time. Basically name it, and you can somewhere get it from these statistics. So it's a really powerful tool to measure performance and also visualize it. And then we look at JDK mission control. As said before, it's completely unrelated. Just for the demo, I do them both. So this is the analysis during the performance run that I just did. For 1 minute, I basically recorded my application. It says, okay, there might be some heap issues. Yeah, of course, it's a really simple demo, so that's not really interesting. But let's look at some more interesting stuff. For instance, method profiling. Here I can see how much time was spent in which method of my application. So now I can see, okay, most time was spent here. So if I want to optimize my code, probably it's a good idea to start looking at that one. Of course, this is a really simple example, so you probably don't see much in this, but we used it in the past, for instance, and I found out that we had a for loop inside a for loop, and after profiling found out that the inner for loop could actually be extracted outside of the for loop and won quite some performance actually. So any information that basically comes from your Java application and the JVM is in here. So also which exceptions are being run, things like thread dumps, but also things like which garbage collections took place when and how much heap memory was used. So you can get a proper idea about the memory usage of your application and maybe configure your heap differently. I mean, in the past, at least for my teams, mostly when you had an out of memory issue, you doubled the heap, right? But it's not always the best idea, because then when it's full again, it needs to collect a lot of stuff. And with this, you get way better insights. And it gives way more stuff as well. So if you like this, have a look at it. Then we go to some more implementation tools. We start with equals verifier. Any of you written an equals method in the past? Yeah? Who thinks it was a proper equals method? Yeah, so that's basically the tricky thing, right? I mean, you can write one, but if it's okay, it's a bit of a challenge. So I also started. So I have a really simple student object, tried to write some equals method, which sort of looked okay, right? I mean, it compares the first name and the last name, which are part of the student. And then I used equals verifier. Sorry, it's at the bottom. So with equals verifier, I can say, okay, check this class and verify if my equals method is properly. You already see here, I get an error message back, which was this one. It found some issues because the hash code is actually not equal. And then I went through it again and created a better example, and this is basically like the better equals method. And if you test that one again, so if the fixed student, then it doesn't throw any exception. So this way you can, for each class that you have where you write your equals method or your hash code method, you can basically make sure that it's a proper one. So it's really simple to use. Next one we are going to look at is handlebars. Any of you got a request recently to join another company from a recruiter? Ever considered joining the other side and become a recruiter yourself? Because this might help you with it. So this is a templating engine. You can also use it for other stuff. You don't have to become a recruiter. So it's basically HTML with some special stuff in it, which we can then replace from our Java code. So basically this is like what a recruiter could send, some technology, how many working hours, what your salary is. Oh, of course, that they never mention the salary, but so let's look how this works. Inside Java, oh wait, I simply make it completely big. So we can say, okay, this is my handlebars example. And then I basically go and fill in some information. Now, the first name, they also always forget it, right? You get some weird stuff for the first name. GraalVM experience should be at least 20 years, right? If you do anything in Java, PHP could come in helpful as well. For some people, J2EE still exists apparently. You need, of course, a really good title. Senior developer doesn't cut it nowadays. Let's see. Salary, yeah, some random number, and the working hours is also some random number. So let's do this. So I simply output it to the console, but you can also output it to an HTML file or whatever. So now you know why you always get these weird names where they didn't fill in your name. They basically forgot to do the right templating. So this now it's all filled in. 54 hours a week, I think is quite good, and salary of 353 euros a month is also quite good, so I would apply immediately. So without kidding, I mean, if you do any HTML templating, maybe sending customized emails or stuff like that, this can be really helpful for it. And then we go to Java Poet, which I think is one of the coolest names you can give to a tool. So what does Java Poet actually do? Java Poet allows you to dynamically construct Java classes. So let's say we want to create this class. Relatively simple, first name, last name, etc. Then we can do it in this way. So we can create a set first name, get first name. Let's see, what was this? This creates the constructor. This creates the class. And then I can automatically basically generate it. If I build this, I run it. And I get the class above. Probably now you think, why? And if you don't think why and go and do this on Monday on your code base, then don't tell your colleagues I recommended it. So this is really powerful. If you, for instance, create libraries that need to create classes on the fly, a lot of libraries use this tool. Of course, you shouldn't use this in your normal application because it's completely unreadable. But if you dynamically need to create classes, this is really powerful. So it's used in quite some cases. So if you ever have the need, yeah. So the question is, can you also change existing code with it? I'm not 100% sure, because probably then you need reflection and stuff to do that. So I don't think it works out of the box. I only tried it for creating new code indeed. Yeah, but it's a good one to try out. Yeah. Then we come to the next one. Job runner. Oh, don't press any keys. So if you have any questions about this one, ask the gentleman who just asked the question. He created it, so probably knows a lot more about it than I do. But with Job Runner, what you can basically do is any job scheduling, and it's nicely persisted and everything, so you can run it in clusters and things like that. So to show some examples here, for example, I have a job, and I say, okay, this should be maximum retry 1, and of course it is retried because I throw an exception. So, for example, if you want to create a database backup once a day in the evening, maybe the database is down just at that point in time or a bit slow, you want to retry it a couple of times, you can easily do it this way. You can also do like recurring jobs with some cron expressions to define at which time they actually need to be executed. You can also create them programmatically. So for example, here you can see, okay, at this time plus 2 seconds do this, or schedule every 15 seconds. And here I, for example, the annotated one which I just showed, I queue it. I can also run this, and then they're all executed at various points in time. So if you have some scheduling thing that you need to implement, this is a really nice tool to use. So here you see it's an exception, so it triggers retry. You see all the other jobs as well being executed. Here it's the recurring job, the retry again. So it retries 2 times just as specified. So it's fairly simple, but really if you are in need for some scheduling, then really try this one out. And then we come to JSoup. I hope you already had lunch, because else you might get hungry. So with JSoup, you can actually communicate with some HTML. So in my case, I create Chocolati packages to install Java on Windows. There is a website which shows how much downloads I have. Of course, statistics are cool. So I can basically try and retrieve the HTML page. And here I basically have like my query inside HTML. And now, of course, internet probably went down or something like that. But with this, you can basically query your entire HTML page based on, for example, the CSS tags, and retrieve some data out of that HTML page automatically. So it's a really easy tool to use. Then we come to lib phone number. This, yeah, I don't know if I should really show it to you actually, because some websites, you need to fill in your phone number, because I mean they want to call you. I never want to get called actually, so I fill in a random phone number, preferably some completely random so that nobody else gets called. But yeah, you know how it goes. I don't know how about you. Maybe you all politely fill in your own phone number, maybe not. With this tool you can actually check if someone entered a valid phone number. So you can still fill in your neighbor's phone number, but at least it has to be a valid one. So let's look how it works. Here I have some number, which is a Dutch number. I can parse it, check that it's from the Netherlands. I can see if it's a valid one. And if it's like a landline number, I can even see from which town it is. If it's a mobile number, I can, for instance, see what the carrier is. And it basically doesn't matter how you put in your phone number. So with zeros or the plus sign or whatever with spaces in between, it will parse it nicely, and it will say whether a phone number is true or not true. So like this one, it misses a few digits, so it says false. So if you ever really want to annoy your users, use this one in your application. Don't do it on applications that I use. I had an example about MicroStream, but that was already covered this morning, so I will skip on that one. And go for the Optaplanner one. Oh, sorry, Timefold nowadays. So basically, if you're familiar with it, Optaplanner in the past, it's now forked and it's called Timefold, forked by the original creator, who now maintains it under a different name. So those are the 2 names that you see for it nowadays. I can run this application, and what I basically did is I tried to automatically come up with a good schedule for a conference. Let's say Richard here did an awesome job making sure that every room has the proper sessions in it, but it's a lot of work, right? You have like, what is it, 5 parallel sessions all day, even during your lunch break, for multiple days, and you all need to schedule that somehow. With Timefold, you can schedule these kind of things, but all kinds of planning problems you can do with it. Also like delivering goods efficiently or things like that, that's all covered by Timefold. So I just show one example, but if you have any other things that you need to solve, you can use it as well. So how does it work? For example, what I say is, okay, a room can accommodate at most 1 session at a time. Because yeah, it would be annoying if another speaker was standing here telling another story, right? At least for me it would come quite confusing. And we do that with just a few rules, like, okay, time slot is the same and the room is the same. That's it. A speaker can also teach almost 1 session at a time, except of course when he's Venkat, then apparently he can do multiple things at the same time. At least that seems like. A a speaker also prefers to teach in a single room. I mean, we're all developers, we prefer stability. Having to go from one room to the other, again, getting familiar with how everything looks like and stuff like that is difficult. So if a speaker has multiple sessions, they're all in the same room. If speakers have multiple sessions, I mean, they are really privileged, right? So we should punish them a bit. So they get all the sessions back to back, no pauses in between. And then it could be, I think it's here as well, right? There are some sessions in German, some are in English. You could spread them over all the rooms. You could also decide like, okay, we have one German room and one English room, something like that. So in this case, I try to separate the languages in different rooms. So I think the application, I already started it, so, or not. Okay, let's check what went wrong here. Did I miss clicking it? Oh, yeah, other application was still running. Of course, it doesn't work. Let's start it again. So now it should be up and running. So here we have our schedule. It's a relatively easy one. We have 4 rooms and a few slots. And here are all the sessions. So now I can click on solve, and it will automatically try to solve the puzzle basically for me. And it did a fairly good job. You see here, for instance, okay, these are all Dutch sessions in this room. Here we see all English, mostly English. There's one Dutch in between. Here we see a small issue. There are 2 sessions in the same slot. Here as well. Any idea why? Good one. There are not enough slots. Basically, it's my own fault. I have more sessions than slots. Basically, to show you that, okay, you can define rules, but you need to define them properly and still get proper input, else the system still breaks. And there was one other interesting one, which I was a bit puzzled about. So Sander Mak gives great sessions, so he has a lot of sessions back to back. So here he has one, here he has one, here he has one, and here. But here it's missing. I was like, why? I mean, I specified it should be back to back, right? And why does he get a break? He should work, right? And then I found out that actually my rule to check if a session is back to back checks if one session is within 30 minutes of the next one. But the lunch break is more than 30 minutes. It's like an hour. So then basically, again, it's a fault on my side. I didn't create a proper rule. So if you get all the rules set up, you see it's really quick. Within a few seconds, you have a nice overview, which you can then use. You can even customize it more if you want to. So if you have these kinds of problems, have a look at it. See how we going time-wise. Yeah, so next one is Apache Spark. Normally Apache Spark is used, let's first start it because it takes a little bit of time before it finishes. Normally Apache Spark is used for like really big data sets or really tough algorithms that take quite some time, and then the calculations are distributed across multiple machines. So you could, for instance, run it in the cloud on like 100 machines and then distribute the work across 100 different machines and then combine the result again. I found another use case for it. I always struggle with Java to read files. You need to figure out how you open the file and then parse it and everything. And then this time I had a 29 gigabyte file from Amazon with all the reviews on Amazon products, because I think that's really useful. And I wanted to parse it and see for text that contains, I think it was Java programming language that I tried to filter out. So you can see it here. So all the reviews that contain that text. I tried to do it in Java, basically to compare it with doing this in Spark. After finally getting to read the file, took quite a while, and then it went out of memory. Because, I mean, yeah, 29 gigabytes was a bit too much, apparently, for my laptop. So you can use Apache Spark to read files, apparently, and to do a lot of big data processing. And to show you how it works, so basically I read in all the lines. I convert each line to a class, basically just a few simple files, and then I can loop over that data. And for instance, in the end, check, okay, I have 28 results, for example, and then 28 results of the Java programming language. And I can also measure the duration. So let's see if it's already finished or not. What, that was the other screen. It's still running. So it takes about 2 minutes to parse 29 gigabytes of data, which I think is quite impressive on just my laptop going through all those data records. So even if you don't have like really big data setups with multiple nodes and stuff like that, might still come in handy if you want to do some local processing in an easy way. So the question is, does it support any file type or text only? You can do anything with it. It's basically you extract data and it works like just normal Java. So you could also retrieve data from a database and do calculations on top of that with Apache Spark. Yeah, so with Apache Poi you could read the Excel file and then retrieve all the data from it and do calculations inside Apache Spark. Apache Spark, you can see it maybe a bit like a thread in Java. You can just run stuff on it. So you can basically do anything with it and use your other libraries that you already have to assist Spark in retrieving the data. Here we see it's done. So 41 million records in a bit more than 2 minutes this time, 2.5 minutes. So yeah, quite nice, I would say. Then toggles. Whoever went to a conference session where they talked a lot about feature toggles, feature flags and stuff like that? Ever tried it in your application? Often it's more challenging than they tell you. I mean, at Netflix apparently they know how to do it and it sounds really easy, but then you try it yourself and often you end up with 2 million feature flags which are still somewhere because it's not completely sure if they are enabled or not. But if you want to have like an easy start with those feature flags, there is a small application to help you with it. It's called Toggles. So with Toggles I can basically define my features. So I have an awesome feature and I have an almost ready feature. This one is enabled by default, this one is not. I have a controller, and in the controller I basically use that feature manager to check if one of those feature flags or toggles is active. Same one for this one. So if I start the application, let's see. What was it? Awesome. Oh, did I again forgot to close my application? Sorry. So my awesome feature, it's enabled by default, so I can immediately see it. Then if I go to almost ready, I don't see anything because basically I only check and else I return empty. If I now go to console, I see this. And this I get for free. I didn't create this. I mean, I'm a developer. I cannot make such nice UIs. But this here, you can see the same status. I mean, this one was already enabled, so it has the enabled status. This one is disabled, but I can change it during runtime. I can say, okay, it's enabled. And now I can go back, localhost, almost ready, and now it's enabled. So it sounds simple, but if you want to do stuff like this, it's really easy. Yes? So the question is, how do you load balance it? I think you have a challenge. You need to do it on all of them, I guess. Yeah, that's a good one, yeah. You could, of course, again, automate that and making calls to all of them automatically somehow with a dashboard, but then it's a bit more work. Yeah, good one. Then we go to some security tools, because, yeah, security is important, of course. So first one is the OWASP dependency check, which we will look at. Let's see, it was just Maven verify. So the OWASP dependency check, basically it downloads really huge reports with all kinds of known vulnerabilities in dependencies. And then it looks at your dependencies to see if they are present in those reports, and if so, you basically get a warning. So let's simply do that on our project. Normally it retrieves those reports automatically from the evil internet every, I don't know, few days. I cached it locally to not depend on any Wi-Fi stuff. Normally, of course, you shouldn't cache this, but use the latest results. And here you see, okay, it found some issues. You can also get an HTML from this, but yeah, this is the easy one. So yeah, log4j, maybe you've heard of it. Apparently some security issues. I guess best way was to solve this was to go back to log4j1, right? Now, of course, these are things that you now need to fix in your application, basically, and make sure. I deliberately put in this example, but normally it will check all your dependencies to see if there's anything present there. Another one which I never knew existed. So when I created this session, I asked other people as well, okay, do you have IDs for cool tools and libraries? And I got quite some interesting results, like for instance, passi. Let's say you write some authentication application and for whatever reason you want to specify the password rules yourself. You could create some regular expression for it, but yeah, at least myself, I cannot read it the next day and probably the next hour already not. You could also use something like passi. So with passi, it's more like human language. Okay, a password should be between 8 and 50 characters. At least 2 of them should be uppercase. At least 3 digits. Should have some weird symbol. Shouldn't contain some sequence stuff and shouldn't contain a white space. And then what I can do is, okay, if I get my password, I can validate it, I can check if it's valid or not, and I can retrieve the messages. So for simply password, of course, that's not really good, so it has several issues. These 3 rules basically aren't properly followed. So the same goes for all kinds of passwords. Here I finally have a valid one, and then I can check that it's valid. So if you ever need to write some password validation, have a look at this one instead of trying to do all of it manually. Then we... how does it compare per performance? I'm not sure, but I mean, I think readability and maintainability often is better than performance. Okay, my Wi-Fi is gone. See if I can quickly reconnect to show. Else I'll simply talk about it. So basically, you have a lot of dependencies. So we saw with the OS dependency check that I had an old version of a dependency. I should update it. You can update it manually, but it's even better if you have tools for it, right? Tools like, for instance, the PandaBot or Renovate, which I show here. They basically create automatic commits showing, okay, there is a new version available. You should update. So this is basically a pull request, and I only need to accept it and merge it, and then it's done. You can even configure it that it automatically builds your application again, and if it's successful, automatically merge it. But yeah, have a look at this one. It's really powerful to get going. Then another example is Open Rewrite. Anyone ever did an upgrade of Java? You're all still on Java 6 or 1.2? Even better. Stability, right? Yeah. So basically, in the past, we could do it all ourselves, those upgrades, and not only Java upgrades, by the way. So Open Rewrite, it's sort of recipes which are applied to your code base. So you can also use it to upgrade from JUnit 4 to JUnit 5, if you're already on JUnit 4, because maybe if you're still on Java 1.2, you're still on JUnit 3 probably. And so this is really powerful. There is a session about it later as well by Tim, where he explains more, but let's give a quick sneak preview. So I basically let it run, and then it automatically updates my application, in this case from JUnit 4 to 5. There is one to upgrade to Java 17. I think they also have some migration stuff, like from going from Spring Boot to Quarkus and stuff like that. So there are a lot of different recipes that are available, and then you can basically look at it with Git or whatever. So here we see the new dependency, Jupyter for JUnit 5. 4 dependencies removed, but we also see it fixes other stuff, like my formatting. It's automatically fixed by Open Rewrite. And if we look at the tests, it also tries to improve my tests automatically. For instance, how the exceptions are being handled changed a bit between JUnit 4 and JUnit 5, and it automatically transforms it to make them better readable. So I think that's quite nice. It's not simple one-on-one migrations, it even improves your code base. So if you ever have to do one of these migrations, have it a go. I mean, if it doesn't work on your code base, it doesn't cost you much time. If it works, you don't need to do the migration by hand. Yeah. Really good question. So the question is, what if I am the author of a tool? Can I provide these recipes? Yes, you can. For example, as I mentioned, OptaPlanner is now called Timefold. The author has a recipe to do all the changes from OptaPlanner to Timefold. And I know there are multiple frameworks nowadays that do it. So it would be super awesome if all the frameworks would do it, because then upgrading would be really easy for us. So I think we're going towards a way of working where upgrades are getting easier and easier, basically. At least that's what I hope. Then one last one. Who's using Maven here? Yeah, the rest is using Gradle? Or not even using Java, maybe? And so let's say in Maven I compile everything. Do a Maven compile. I grab a coffee. Who has used Maven daemon already? So you already know the result, but don't spoil it for the rest. And so we see here it takes about 11 seconds. If I do Maven daemon and do the same thing, and a Maven daemon, it's just a tool that you install. So it just runs on your machine. You don't need to change your pom.xml or anything for it. It's just an extra tool which you install. You can even give it another name and simply call it Maven if you think the D is too difficult. First time it takes a little bit of time because it needs to start up the daemon. After that it's running, so like a second run mostly is a bit faster. And you already probably noticed this is a bit quicker, right? So 6.7 seconds. Oh. .2. So that's, I think, like 1/3 of the Maven execution time. So now you can either opt to, on Monday, start using Maven daemon, or you can opt to keep drinking more coffee while building. It's up to you. So that was basically it for now. The time's basically up. So if you, there are many more tools. I try to show as many as possible. But if you want to see more of them, please have a look. And then I have one question for all of you who already knew all the tools. Most of them, good. But you learned something new, right? So next week you can try out the new tools if you like it, or whenever you have a good use case for them. And so I hope it was useful. As mentioned, I think time's now up, but I will be walking around. So if you have any questions, feel free to approach me later. And with that, I would like to thank you all for joining.